Okay, so in this video, we're going to be touching upon a comprehensive question on capital budgeting that you may see on a final exam, group project, or homework/assessment in your intro to finance class as an undergrad, or a recap on finance during your MBA or master's, and even within your CFA level 1. In this video, you're going to understand how to look at an ambiguous question like this one and walk through it effectively and really make sense of it from any different angle that works best for you. So let's break it down, let's get through it, and hopefully this empowers you, okay? So in this question, we have the following. Suppose that Shai Designs wants to open a new architectural division in Dubai. However, the CEO seems unsure of the viability of this project. The CEO gave you the following information to guide you in evaluating the soundness of this project. The first bullet point informs you that the internal rate of return of the project is equal to 14.44%. Now, I want it to be extremely clear. The internal rate of return is the point at which is the K that's going to provide you an NPV equal to 0. Okay? That's extremely important. And they're also letting you know that the firm's discount rate trends towards 10.28%. So the firm's discount rate, well, that's the K, right? That's a discount rate, literally, of the firm. So that's important. What we're doing right now is we're just highlighting the information and then adding some context to it as we proceed. So that's always important. So we have K is equal to 10.28%. The project timeline is 5 years. So there will be only 5 payments, or the project will be over in 5 years. So that's pretty relevant. And it's also letting you know that this project will require an initial investment of $350,000. So CF0 is going to be equal to 350K. That's always amazing. So CF0 is equal to 350K. It's awesome. If we continue, from the end of year 1 all the way to the end of year 3, this company expects to receive after-tax cash flows of $95,000. So what this is telling you, and I'll zoom in a little bit just to really dive deep and write this in, is we're going to have, okay, payment 1 all the way to payment 3. Well, those payments are going to be equal to 95K, every single one of them. So payment 1, payment 2, and payment 3, they're all going to be equal to 95K each. Okay. Then the question is also letting you know, well, the cash flows of year 4 and year 5 are unknown. That's extremely important. So what this is telling you, and I'll zoom in again, I'm sorry about that if I'm giving you like vertigo or something, but what this is telling you is that payment 4 and payment 5, they're both unknown, okay? And they're equal to each other if you read a little bit more. However, they must be equal. So payment 4 is equal to payment 5. And we know that they're unknown, such that payment 4, for us right now, we could call it X. And by definition, payment 5 would also be equal to X. Okay, so that's just something to kind of keep in mind. Okay, and we're also letting you know, well, given all this information, okay, given all this information, what will be the project NPV? All right, and we're going to highlight this in red actually, because that's our mission. That's what we're solving for. We want to know what is the project's NPV given all of this information. And we're given a lot of information, right? Like if you see this on an exam and it's the first time that you see this on an exam, you may be kind of confused. And this may seem like something that's overwhelming. But what we're going to do here, and we're going to use a technique that we adopted within our chapter 5, time value of money, in which we are always going to build a timeline to kind of start off the question, to make it easier for us. So what I'm going to do is I'm going to zoom in a little bit. And we're going to build a timeline to establish some sort of context. Then you'll notice that with the tools that were given to you, there's actually a few things that you could do to find the answer here. So let's begin with building our timeline. All right, sorry about that, I'll just zoom. So first step, build your timeline. Okay, make that. Oh man, I'm so cringe. It's actually ridiculous. So here we're gonna have t equals 0, t equals 1, t equals 2, t equals 3. Well, it seems like we don't have enough real estate, so I'll zoom out a little bit. Make this a little bit longer. And we're gonna have t equals 4 and t equals 5. Now, you're probably a vet when it comes to building timelines, but we're gonna go ahead and just go with the classic steps. We're gonna, oops, sorry about that. We're gonna just place in all of the data that was provided in the question. Okay, we're gonna do exactly that. So we're gonna go ahead and I'm gonna move this a little bit just for my own sanity. And by the way, I'm sorry if I take my time. Don't hesitate to skip through the video. It's totally fine. So in this case, let us write our cash flows. We know that upon the initial investment, so today, we have minus 350K. So we have this right here. Okay, so this is gonna be our CF0. And we know that our payment 1 is gonna be equal to 95K. We know that payment 2 is equal to 95K. And we know that payment 3 is equal to 95K. However, and I'll put this, I guess, in blue, payment 4 and payment 5, we don't know what they're equal to just yet. And that's what we're solving for. So we can go ahead and maybe highlight this in yellow, just to say, well, we don't know what's going on right here. We don't know what to do with that, okay? So that's gonna be pretty relevant. Now, what's awesome here is that the question gave you a few points, okay? And by the way, even before we get there, notice how we have a simple timeline. Notice how this looks exactly like chapter 5, or our time value of money chapter. So this should ring a few bells. But what's even better here is that they gave you the IRR of this entire project, okay? They gave you the IRR of this entire project, and they also told you, if we highlight this again, that payment 4 and payment 5 are equal to each other. This is awesome news, because you're able to actually use this to your advantage and solve for the missing variable by using the IRR. You'll see what I mean in just a second. Check this out. We were told that the IRR of this entire little project is equal to 14.44%. So what is this telling you? This is telling you that you could actually solve for the missing variable. And I'll show you how to do that in an effective way in just a second. Right? So you'll see what I mean. This will be step 1. Actually, we'll just leave it like that. It's whatever. All right. And I keep on doing this in every video. That's crazy. Sorry about that. In every video, I always click the text box and it throws me in God knows where every time. Very strange. Anyways, but who's the fool here, right? The person that keeps on making a mistake, right? Or the software that makes a mistake. I think it's me. I think I'm the fool. Anyways, that said, what we could do here is we could actually solve for x. And the way that we're going to solve for x is knowing that the IRR is equal to 14.44%. The reason why we could do that is because we understand that if the IRR is 14.44%, that's the point at which the NPV of this project is equal to 0. So we know that we could write this perhaps a little bit cuter like this. So we could say that, well, I guess I'll zoom in like this. This is the point at which 0 is equal to present value. So the sum of the present value of your cash flows minus CF0. Okay. You could also write this as being simply payment I over 1 plus K power of I minus CF0. Okay, so this is a few ways that we could write this. And the reason why this is pretty important is because now we could go ahead and essentially do the following. So we could say that 0 is going to be equal to, in this case, we're going to have 95K over 1.144 to the power of 1. We could do this a few times like this. Let's see what I'm doing in just a second. Let's check this out. So what did I just do here? Well, the reason why we could do this, and I'll zoom out a little bit. Apologies for not speaking too loud. What we're doing here is that we know that we have the following cash flows. We know that, actually, I'm just going to add one last part, minus 2,000. Sorry about that. Okay. So we know that what we just did here, well, this is displaying exactly what we highlighted at the bottom here. So the sum of the present value of cash flows. So these are all the payments that we have. So we have payment 1, payment 2, payment 3, payment 4, and payment 5. And they're all being discounted at the IRR. Because we know that these cash flows, okay, discounted at 14.44% will yield us an NPV equal to 0. And notice how this is literally the present value of all your cash flows. And this is going to be your initial investment, such that we're able to solve for X. It's really as easy as that. Now, on an exam, do you have to do every single one of them one by one? Well, not necessarily. There's actually a tactic that you could use to make this simpler for you. And if you see my other IRR videos, you'll notice that that's a pretty easy trick. So I'm just going to move our things a little bit to make this cuter, and then you'll see exactly what I mean in a second. Now, once again, I'm just taking my time because I want this to be something that you could look at afterwards. That's going to be empowering. That's going to be easy to kind of comprehend. So for sure, I understand, if this is a little bit long, so you could always, once again, skip ahead and, go at your own pace. That's totally fine. Okay. So we're going to get the following. I think I'm going to erase this. The duty of this is to make sure that it looks good when you study. So now that you have all this information, what you could do is really simple. We could actually highlight a few of these pieces and do a little bit of a magic trick. So you're going to see what I mean in just a second. Check this out. So what we could do is we could group all the values that are known. Okay, and we could make it as being like its own little thing. Check it out. You're going to see what I mean in a second. So we could group what I highlighted in yellow as being part of our CF function on our calculator. Because technically, what we could do here is that we could say, well, you know what? if we assume that these cash flows they stopped at year 3, well then we wouldn't need to solve for x, and we would be able to yield a net present value for this portion of the project. Okay, and this portion of the project plus these two must be equal to 0, and that's going to make the solving process for these like two things that I highlighted much easier for you. You'll see what I mean in just a second. So what you could do is you could go on your calculator, go on your CF function, do second clear, and you could place in CF0 as being $250,000. Okay, so you could do that, negative, enter. Then you could go to CO1 and put $95,000, and then do FO1 as being equal to 3. All right. So if you want to see what that looks like, you would have CF0 minus 250K, CO1 95K, FO1 equal to 3. All right, such that you could simplify this formula in a way that's actually like mad easy for you to understand here. All right, so you can do that. You can make it much easier for you to actually navigate this question. Okay, I guess I'll zoom in a little bit like that here. We're going to continue the rest over there. So what you could do here, and I'll write a little note, such that it's simple. And if you didn't understand, you could put CF0 is equal to minus 300. By the way, it should be minus 350K or minus 250K. Minus 350K, not bad. Sorry about that. You get the gist of it. I'm just giving you techniques that you could use and that you could get, you know, a larger perspective on what we're doing. Okay, so you could use this to your advantage if you're ever kind of reviewing what we did. And if you want to find a way to do it quicker, such that in this case, what you're going to have now is you're going to have the following. I'm going to zoom in a little bit. So minus 30. So you're going to get 0 is equal to, I guess we'll copy what we had at the bottom. Go here. Equal to this minus 131,000 0.63. Okay, and now it becomes easy because now all you have to do is solve for x. So that was like a little trick to show you how to solve for x in an easy way. Hopefully it helped. I don't know. We'll see. And now you could just, once again, simplify further. You would have something like this. Then you could simplify further. You have something that will make it easier for us. We're going to solve for x. Now, this is my first time doing it, so I'm going to use Symbol Lab to do it. You could solve for it in the meantime. And you would get that x is equal to 119,967 0.62156. Now, why is that important? Why does that matter to us? Well, because now we found our missing payments. Now we're able to work with that. We're able to actually get a value that matters, something that we could plug in order to find our NPV. Now on an exam, because this is the first time I've actually done this question, I'm actually going to review this. And the way to review this is going to be simple. I'm going to put my CO2 as being 119.967.62156. Enter that. My FO2 as being 2. I'm going to review everything one last time. Cool. Then I'm going to go to IRR and I'll press compute. And I get 14.44. It's almost like I teach this for a living. So now that we have that, we could actually move on and solve for our NPV. And our NPV is going to be mad easy, okay? Our NPV will be very easy to compute because all that you have to do now is you have to just plug in all of these things within your calculator, such that if we go here and we copy what we had written here, we could actually use this again. It's crazy to recycle your work. Okay, we can zoom in a little bit. What you're going to do now is you're going to plug in, I guess we'll put in another color, here's CO2 is being equal to 119.967.62156. You're going to put FO2 as being equal to 2. And then it's simply compute plus NPV. All right, it's really as easy as that. Okay, so what we're going to do now together is we're going to make sure that we have all these inputs. So we're going to go to CF0, it's minus 250K, CO1 95K, FO1 is equal to 3, CO2 is equal to 119,967.62156. Yep, FO2 is equal to 2. So we have all the good inputs. Then you go to NPV. What you're going to do now, though, is really important. Okay, so I'm going to put this in green. Don't forget to plug in the right, I. What you're going to plug in now, okay, is you're going to plug in I equal to 10.28% or whatever it was that was provided in the question. Yeah, you're going to plug in I is equal to 10.28%. Because that's what we need here, right? We want to use the correct discount rate. We don't want to use the IRR because the IRR, well, that's the point at which we know our NPV is going to be equal to 0. We don't care about that point. Now we want to figure out what's our NPV with our discount rate, okay? So you do enter, and you do compute. And you're going to get something really interesting. You're going to get an NPV that's equal to 39,751.28.211. And that's going to be your answer. All right. Now, this was a long one. Like, I know we took our time, but it's really to, one, have some sexy notes that you could review later, but also for you to really see every single step in its context, right? The first thing that we did is we drew a timeline. And we noticed that, okay, payment 4 and payment 5 are cash flows that were missing. But what's awesome is that with all those cash flows, they gave us a really crucial point of information. They told us, yo, IRR is equal to 14.44%. And the reason why the IRR matters to us is because it allows us to solve for the missing variable. It allows us to solve for X, X being these missing cash flows. So then you know that it's equal to that. You could do 0 equal to the present value of your cash flows minus the initial investment. I showed you how to use a calculator to kind of expedite that process, but you could also go one by one. Both methods work. Then once you found X, all you got to do is plug that stuff in within your financial calculator and solve for the NPV. But you cannot forget to put your I as being equal to 10.28%, because now we don't care about the objective point at which we're indifferent, right? The objective NPV at which is equal to 0. Now we want to find our NPV with our subjective stance with our discount rate equal to 10.28%. And you notice that we have an NPV that's positive. And a clear takeaway here for you is that NPV positive means you're happy. NPV negative means you're unhappy, right? Because now you're able to essentially have an I, a K that's smaller than the IRR, and that's a big W. So with that said, I hope this video was helpful. I hope it gave you context. I hope I wasn't, annoying, and that you're more equipped now to solve a actual final exam question, like 100%, that is complex, ambiguous, that requires you to put things together and actually put in the steps the right way. Because oftentimes you're going to have a multiple choice, and your partial, your work along the way won't matter. So with this stuff, I hope that you're more equipped. I hope that you feel, better. And if you need more content, if you need more information, you could always go on eastmyhelps.com. You can go on my YouTube channel as well. And the reason why I do this is because I want to give you an opportunity to learn in a more human way, an opportunity to learn with a fool like me, somebody that's like you, who took the class not too long ago, that understands how frustrating it is to not have the resources that you believe are needed for your success. And hopefully, maybe this isn't the whole solution. Maybe it's one step towards that. And hopefully I'm able to, bring you there. That said, enough of spieling, or enough of my spiel. Continue working hard. You're an absolute warrior. You're awesome. Keep on working. You're doing amazing. And we'll see you in another video. Bye-bye.